Hello, I'm at Ljungbyheds Flygklubb now. Since the Saab Safir is damaged and the Cherokee, or whatever the name is on it, is very often occupied, I have to find out something else to fly. Then we have this plane also in the Aero Club, Ljungbyheds Aero Club. I don't know anything about it, and I'm about to learn to fly it, but I know lots of things generally about planes. So I'm thinking about going through the plane with the engineering pilot's view of the whole thing. I haven't studied anything, but I want to take a look at it first, so it's much easier to read in the documentation about the plane after when you have seen it. So that's my way of approaching it. Starting at the front, we have a 180 horsepower, because I see the 180 in the back, that's all I know. But the 180 horsepower 4-cylinder boxer engine doesn't sound as good as the 6-cylinder on the old Safir, of course, but that's a modern trend. You get now 180 horsepower up to a 4-cylinder. Then we have a variable pitch propeller. The pitch of the blades can be varied, and you use a low pitch at low speed, takeoff, landing, and you use high pitch for cruise when you have cruising speed. It works just the same as a gearbox on a car. Low gears when you're driving slowly, and high gears when you get the speed up. That's very much more efficient than a fixed blade propeller. 3-blade, which is quieter and very nice too. Then we have the small hatch for where you check the oil. And below the plane we have the exhaust. I wonder why planes very seldom have mufflers or silencers. I don't know really. It should decrease the sound level from propeller or piston engine planes, but I don't know. Maybe it's because it adds some weight on the plane that hurting the performance. And then you have the nose gear here, nose wheel. It's obviously not steerable like the Cherokee. If you press the rudder pedals on the Cherokee, the nose wheel turns, which is very, very easy to control the tracking of the plane on ground, but it doesn't give very good feeling in the rudder pedals. It's actually rather awful. It's heavy and not so good. But this one is not controlled at all. Instead you control the plane via the rudder, and then possibly you have to add thrust to the engine to get the aerodynamic flow of the rudder, and if it doesn't help, then you must use differential braking. You use the left brake to turn left and right to turn right, of course. It's a bit tricky maybe, but I like it a lot because it gives so much better feeling in the flight controls. So I take that. A bit tricky when you have crosswind, for example, because then the air pushes on the vertical stabilizer from the side. Anyway, you learn. Okay, if you go back on the plane, you enter from the front here, have a footstep, and you step into the plane. Then the wings are very, very clean and smooth. Have fuel tanks in the wings, and you have a quite interesting wingtip here. You know, there's always lower pressure on the upper side and higher pressure on the underside. That's why planes are flying. And if you make a smooth transition here, you reduce the induced drag a lot, because there will be a vortex coming like this. And if you make it smooth, the vortex will be smaller. And this is very nice done. And if also the ailerons here are very, very smooth. If you put the stick to the right, like you see here, the ailerons go up. That reduces the lift on the right wing, and at the same time the ailerons on the other side go down, and the plane will bank to the right. That's how you roll the plane. Very smooth surface on the flaps here, beautiful, and no step from behind. If we move further back on the plane, we can see that it's a T-tail here. That's interesting. Advantage is that it gets out of the way when you walk here. I have it over my head like this. And there might be some disadvantages with the T-tail. I don't know about this plane because I haven't flown it. But if you have high angle of attack when the plane is doing like this, and you coming close to stall, the airflow is separating from the wing, and that separated airflow might hit the stabilizer. So you might get very violent vibrations, buffeting, which is good. Then you feel that you are approaching stall, but it can also reduce the effectiveness of the elevator and also the stabilizer, of course. I know, like MD80 had a very inefficient stabilizer at high angle of attack, so there were some measures to fix the problem, but can be here too. I don't know, we'll see. Here's a stabilizer trim which you adjust to have the plane flying straight and level without any force in the pitch direction. And here's a fixed metal plate for the rudder trim. You know, small planes, they are always aerodynamically stable in pitch because you don't have bunch of computers fixing the stability. So for planes like this, there's always a downforce on the stabilizer. That's not very efficient because if you have a downforce here at the stabilizer, you have to compensate with more lift on the wing. And more lift on the wings gives more induced drag. You know, we talked about that earlier. So a canard design is always more efficient. And if you need more lift from the wing, like when you want to pitch up, that's a reaction of increased downforce on the stabilizer. So first you have to get more downforce on the stabilizer, then the angle of attack increases, and then you get more lift on the wing, and the nose will go up on the plane. So a canard design is much more effective. That's also valid for planes like the F-35 and the F-16. You first have to create an increased downforce, and then you get more angle of attack and lift and nose up. That's why Eurofighter, Rafale and the Saab Gripen, they are much more agile because they can create lift immediately from the canard, and more lift immediately gives more lift immediately from the wing. So they are much more agile in pitch. Stability, more or less, yeah, you can fix that with computers on the F-16 and F-35, but you can't. It's always so that the canard is more efficient, because then you never need to have a downforce here creating the reaction. Interesting. And here you have a skid, so you don't damage the rudder if you have high nose on the ground. Very nice. Okay, always lift on the wing so you can fly with a wingtip like this for induced drag. And here you see something interesting. Always downforce on the stabilizer, at least on the aerodynamically stable plane like this, more or less downforce. And here you see the tip of the stabilizer is angled the opposite way as the wingtip, which of course means that there's always downforce on the opposite to the wing. So here you have less induced drag on the stabilizer. That's beautiful. Checking out inside. A lock here. Maybe it's a lock on the other side too. No. Okay, so that's how it works. You just lift like this. Well, this is very nice. You have super visibility, and you have a stick. I really look forward to this. Also, seats in the back. Okay, stepping in. First impression, very, very good. Because it's a stick, and it's totally superior to a, well, sorry, stupid joke. It's not a bicycle, it's a plane, and I think planes should have a stick. Now I get the Boeing enthusiast hating me, but sorry, you have to take it. It's classic T, speed and horizon, altitude, and compass, another compass, some, yeah, with a VR. That's very good, and a second altimeter. Super easy, lights, switches down here, radio, and engine instruments over here, and fuses. So this is very nice. Defroster. Here's the lever for the propeller pitch. High RPM, yeah, for takeoff and landing, and low RPM, and then you adjust the pitch with this one. Mixture, and the color coded, rich, lean, and throttle. So you have to fly it with right hand on the throttle and left hand on the stick, but that was exactly what I did on the Airbus 330, 340 and 350, so that's just fine. Interestingly enough, the brain compensates for it, so if you fly with the left or right hand, it doesn't matter. Fuel selector for the tanks, left, right and closed, of course, and here you have the pitch wheel, which is a perfect placement, I think. I just sit here. It's very comfortable, and I suppose you have a great view from our looking out in this plane. So yeah, good. And you have the brakes when pressing down the toes, and here I found the parking brake like this. Oh, that's a very small and convenient switch. Now I have to get home and study the books because I need that too, always on new planes. And then it's time to fly it. Look forward to it. Will be great. Thank you for watching. Thursday I will drive my Mustang on the other side of the airfield, and I go over here and fly the Diamond for the first time. Enjoy and take care. Goodbye. See you Thursday. I never did this when I was flying the 350.